Hello guys, my name is Yael Hernandez. Today I'm going to teach you how to program in VHDL with Quartus 2. We are going to program a Cyclone II FPGA from Altera Group. Let's go. What materials are we going to use? We are going to use, as I told you a minute before, a Cyclone II by Altera that the series number is AP2C5T144C8N, a power supply of 5 volts, a USB blaster from Altera, the wire to connect the FPGA to the power supply, jumpers, 4.7 kilo ohms resistance, 330 ohms resistance, 4 LEDs, 1 deep switch of 3 switches, and wires. Okay? Let's do it. Problem statement. In a television program, there is a game in which these 3 people participate. Each participant has a switch. The closed switch on position generate a logical 1. The open switch off position generate a logical 0. On the other hand, there are 4 indicators, LEDs on a board, A, B, C, and D. An indicator turns on if it receives a logical 1. Indicator A turns on only when all players turn their switches on. Indicator B turns on if only A is off. The indicator C turn on if only 2 or more players turn on their switches on. The D indicator turn on if 1 or none of the players turn their switches on. Okay? Analysis of the problem. We have 3 people who can turn on or turn off a switch at their convenience at any time. Their behavior can be predicted with a truth table that represents all of these possible movements. From the analysis, we obtain the equation of the behavior of the LEDs. Here we have the truth table with the person 1, person 2, person 3, and the 4 indicators. The first indicator says that it will turn on only when all the players turn on their switches. That's why we have a 1 here. LED 2 will turn on only when switch A is off. That's why we have only 4 ones when the switch 1 is on 0. And we can predict the behavior of these LEDs with this truth table. For example, for LED 1 only lights when A and B and C are on. For LED 2, this LED, if we notice, it's the inverse of switch A, therefore responds to the negative of A. For LED 3, lights when B and C or A and C or A and B. And for LED is the same as LED 3, only we need to invert the answer of the equation. Okay? Let's go. The first step is start Quartus 2. The second step is to create a new project. We need to go in the up part of the window to the icon File. The second step is to create a new project. We need to go to the File section and we need to select Create a new project wizard. First, we have the introduction for the new project wizard. We are going to click Next. Next, we need to select where the file is going to be, the directory. And then we need to name the file. In this case, we called Juego. Next, it asks us if we want to add other file, but we don't want to add other file, so we click next. Then it asks us for the device that we are going to use. We are going to select Cyclone II, Quartus 2, the AP2C5T144C8 model of the Cyclone II, and we click next. Next we need to put next again because we don't need this window, and this is the summary of our project, so we put finish to continue. The step 3 is create a new VHDL file. In the icon of file, we are going to select new and VHD file and OK. The step 4 is to write the code. First of all, we need to declare the library. We are going to use the library IEEE. Then we need to write the entity. The syntax for the entity is entity, the name of the project, that in this case is TV game, the ports, ABC for imports, as logic inputs, and the 4 outputs, let 1, let 2, let 3, and let 4, as the same logic. The step 4 is to write the code. First of all, we need to declare the libraries that we are going to use. We are going to use the library IEEE. Second, we need to write the entity. The structure of the entity is entity, the name of the project, the ports that we are going to use, in this case 3 input ports that are A, B, and C for the 3 persons that we have, and the output ports that we have 4, let 1, let 2, let 3, and let 4 output, and the kind or the type of these values is logic, because we are going to work with logic values. And then we end the entity. The next step is to write the architecture. We can name the architecture with the name that we want to do it, okay? I called operaciones of the project that we have, that is TV game, is this line signal is for declare only auxiliary variables for the operations. I'm going to declare only 2, x1, x2, with the same kind of type of code or logic operation, okay? In this part, in the beginning, we are going to do the operations that we need to have in our outputs. For example, I use the x1 auxiliary variable to declare the operation that the let 1 is going to operate, A and B and C, and let 1 responds to the result of x1. Then let 2 responds to the negation of the switch A. Then we use the second auxiliary variable that is called x2. The x2 is the equation to the let 3 and let 4 that we analyzed before, okay? Let 3 is a result of x2 and let 4 is a result of the negative of x2, okay? And we end the architecture. After we finish to write our code, we need to compile the program. If you don't have errors in the compilation, we can go to the next step. Don't worry for the warnings, we can continue, okay? Next, in the step 6, we need to create a university program VWF. We are going to file, new, and we are going to select university program VWF. and we click OK. In this file, we need to put in the inputs all the values that it could have. For example, in the input A, we have four zeros and 4 ones. In the input B, we have 2 zeros, 2 ones, 2 zeros, 2 ones. And in the C, we have 0, 1, 0, 1, 0, 1. Until we finish this, we are going to compile this file, and the program will show us the response of the outputs. If it corresponds to the truth table that we have at the beginning, our program is working okay. So we pass to the next step. In the step 8, we need to assign the pins. We are going to assignments, pin planner, and we are going to select what pins of the FPGA we are going to use to run our program. For example, what pin is the input, what pin is the output. We select for the inputs pin 41, 43, and 45. And for the outputs, pin 137, 135, 129, and 125. Then we need to tell the program what it is going to do with the pins that we are not used. And for that, we need to select the unused pins for the program. We are going to go to assignments, then we need to select device, then we need to select pins configuration, and this window is going to appear. We need to find unused pins, and we need to select as input try state with wake pull up, and then click OK and continue. Almost we finish. We need to upload the program to the FPGA. In this point, we need to connect the blaster to the computer and to the FPGA, and the FPGA needs to be on, okay? Okay, we are going to Tools. In Tools, we are going to select Programmer, and this window is going to appear. If we don't have the file selected, we need to go to the next step. We need to select File, and then this window is going to appear. This is the location of our project, and we need to select output files. Then we need to select the file with finish in point soft, okay? Our code is ready to be uploaded. We only need to mark the program configure here with a check mark, and we are going to put a start, and the code is going to upload automatically. But if we have never programmed before, we need to select the blaster. For that, I am going to teach you how to do this. How to add the blaster. We need to go to the hardware setup in the up part of the before window, and this window is going to appear. We are going to select Add Hardware and next Auto Detect, and automatically our computer is going to detect the blaster. Then we put OK and return to the other window. In this point, we select Start, and as you can see, the progress said 100% successful. Now our FPGA is programmed. Let me show you how it works. Here I have my FPGA working. Firstly, I connect the FPGA to a 5 volts power supply that is in this part of the protoboard. The next thing that I did was connect the second section of the protoboard to the voltage and ground connection that the FPGA has. Here I have the power supply wire and the ground supply